What nullable means here in database terms, when we say file underscore URL text null or simply file underscore URL text comma nullable, it means the column may contain null. It is not required when inserting a row. In plain English, a comment must have a text. A comment may or may not have a file. If there is no file, to file underscore URL equal to null. So yes, text is required, file upload is optional. That's exactly what nullable means in this context. Compared required versus nullable side by side. Required field, content text not null. This means cannot insert a comment without text. DB will reject the row. Nullable field, file underscore URL text. So this means nullable by default. Comment can exist with no file. File can be added later. File can be removed, set back to null. So the file can exist with no file or this file underscore URL, just like with uploading image or documents. It could exist without um, it could exist without sorry, it could exist without file upload, just like with normal files. Those exist without any file because file is expensive, but you cannot create a blog without a text because that's a requirement for a blog. How this maps to your UI behavior: valid comment submissions, text only, text plus file, file only, no text. That matches real world UX expectation for this kind of CRUD. For a comment CRUD, you have text or file. File only is a weird thing. How this maps to Redux plus Supabase logic: in your create comment thunk, so we have const file URL equal file question await upload file colon null, then await Supabase that from comments that insert open parenthesis open semi-curly bracket next line blog underscore id comma user underscore id comma content comma file underscore URL colon file URL comma closing semi-curly bracket closing parenthesis semicolon. This works because file underscore URL is nullable. If it were not nullable, Supabase would throw an error when file underscore URL is missing. Why file underscore URL should be nullable? Design reasoning. This is important. Files are heavy. Files are optional. Files live in object storage. Database should only store references. So we store the URL, allow it to be missing, avoid forcing uploads for simple comments. This is a good data modeling, not just convenience. Subtle but important detail: nullable does not mean empty string, undefined, optional in TypeScript only. It means the database explicitly stores the absence of a value null. That's why file underscore URL is modeled this way at the database level, not just UI. Final mental model, keep this. Required equal must exist for the row to make sense. Nullable equal optional enhancement. For comments, text to core meaning to required, file to enhancements to nullable. You model this correctly. Yes, absolutely. You really do need to make it explicit in the database SQL, not just handle it in the front end. And your instinct here is 100% correct. Let me explain why in a way that ties together front end, back end, database, OS, and hardware. just like you've been trying to do all along. Short answer first, the database is the final authority. Front-end checks are helpful, but they are not guarantees. So front-end validation equal UX, back-end logic equal convenience. Neither is a security or correctness boundary. Database constraints are. So the final, since those are separate layers, the final constraints is the database. If those are included in a front-end or back-end layer, but it's not allowed in database, it will not be committed, just like with committing stage with the P6 microarchitecture of CPU that we have discussed. So those separation or layers keeps coming back again as an important or as a necessary concept for us to be able to handle the complexity of these instructions and data. Why front-end only validation is not enough? Front-end logic can be bypassed easily. User open DevTools. User sends raw HTTP request. Script, bot, curl, postman. Another app uses your API. Bug in front-end code. Different front-end mobile app later. If your DB allows invalid data, invalid data will exist eventually. The database is like CPU commit stage. Here's the analogy you've been circling around. This is the key. CPU pipeline, instructions speculate, front-end decodes, execution happens out of order, then only the ROB commits only valid results. This is like database. Instructions speculates and front-end decodes, kind of like the front-end or the URL component. Execution happens out of order, kind of like how API does not control the state of the backend, because the code or instruction and data could have different combination. So the change happens over time and the state are different over time and uncontrollable. But it is restricted in the end in the database or in the ROB commit stage. In database, front-end validates form, back-end logic prepares data, API sends request, database enforces final truth. The DB constraint is the commit point. If it violates constraints, flash error. Why SQL constraints must be explicit? Example, content must exist. Content, text not null. This means no comment can ever exist without text. Even if front-end bugs, Redux bug, API mistake, manual SQL insert, the DB physically refuses invalid state. Example, file underscore URL optional, file underscore URL text null. This means file attachment is optional, no fake empty strings. No inconsistent missing file states, clean semantic meaning. So if there's a null, it means just that input is optional. Why heavy front-end validation is insufficient? Front-end validation is like if value equal undefined, return semicolon. Database database constraint is like this instruction cannot commit. Front-end logic helpful, bypassable, non-authoritative. Database logic enforce, central, immutable. So immutable means it cannot be changed. It is also central. It keeps the global and local state of the whole app enforced. And it's kind of like the Redux as well. It keeps the high level and the low level view. But it focused more on the high level integrity of the app. So this is how the abstraction of database works. This is directly connected to your earlier topics. Row-oriented versus column-oriented storage. Bad data, pollutes scans, breaks compression, increased null handling overhead, hurts bitmap efficiency. Column store love predictable schema. So if you have this explicit role in your database, you'll more likely have this predictable schema. Therefore, you can better integrate it with other API before, such as mobile or uh, column storage database. LSM trees and immutability. LSM engine assumes writes are correct when flashed. Compaction is expensive. If garbage data gets in, you cannot cheaply fix it. You must rewrite segments, so correctness must be enforced before write. Third, Redux reducers versus front-end mutation. Same philosophy. Layer component responsibility UX. Layer Redux responsibility controlled mutation. Layer API responsibility side effects. Layer database responsibility final truth. Just like reducers must be pure, database rows must obey constraints. OS and memory model analogy. Front-end only validation is like writing without memory barriers, hoping race conditions don't happen. Database constraints are like memory fences, atomic commit, serialized consistency. Real-world rule used everywhere, validate everywhere, enforce once. Validate in UI, better UX. Validate in backend, clearer errors. Enforce in database, correctness. Best practice SQL, what you should actually write. Create table comments, open parentheses, next line ID, UUID default, gen underscore random, UUID, open and close semi open and close parentheses, primary key, next line blog underscore ID, UUID, not null references, blogs, open and close parentheses inside this ID on delete cascade. Next line user underscore ID, UUID, not null references, auth.users, open and close argument ID on delete cascade, comma, next line content text not null, comma, next line file underscore URL text null, comma, next line created underscore at timestamp with time zone default now open and close parenthesis, comma, next line updated underscore at timestamp with time zone default now open and close parenthesis. Close parenthesis semicolon. This is correct, safe, and future proof. Why did suddenly click now? Because you've been learning CPU commit stages, while in LSM durability, SQL abstraction versus implementation, immutable state, controlled side effects, and now you're seeing the pattern. All robust system push correctness to the lowest reliable layer. That's the deep reason. So, what comments with file CRUD that I implemented on my blog app means and how it relates to everything we discussed before: Redux, SQL, column or row, CPU log, why your mental block is normal, and what finally clicks now. What is this comments with file CRUD actually mean? Means at surface level, you added a new domain entity comment. So it's the table with structured data, content, comma, user underscore ID, comma, blog underscore ID, next line optional binary file upload. Manage across database, Supabase tables, storage, Supabase buckets, state management, Redux slice, UI, React components. That's it, but architecturally, something important happened. You introduce another independent data stream that must stay consistent across layer. That's the key. Second, how this connects to everything we discussed before. I'll map this layer by layer, exactly like you asked. A database layer, row store slash column store analogy. Your comments table is row oriented. ID, comma, blog underscore ID, comma, user underscore ID, comma, content, comma, file underscore URL, comma, created underscore at. Why row oriented? CRUD heavy, small records, access pattern, give me comments for blog X. OLTP style, this matches what we said earlier. Row stores are optimized for writes plus point reads. Comments are OLTP, not analytics. If you later wanted top commenters per day, average commenters per post, then you'd introduce aggregates, possibly materialize views. But right now, row store is correct. So if you want to provide that, kind of like the leaderboard, that's actually, or top comments per day are actually implemented using aggregates or materialized view from column storage engine. Supabase storage files is not equal rows. Your files are not stored in the table. Why? Because files are large, variable size, poor cache locality, bad for row engines. So you store file to object storage, URL to row store. This is the same separation of concern as heap file versus index. So the heap file, the one that we use to kind of find the next pointer in B-tree, and the index for key value pair. Data pages versus metadata. L1 cache versus RAM. You already applied a storage engine decision without realizing it. Redux slice equal in-memory materialized view. Your comment slice is the most important connection. Comments colon comment open and close square bracket, next line loading, next line error. This is a materialized, denormalized in-memory view of back end state. So this Redux slice is just a view, or kind of like a slice of the entire state of your database, but it's not entirely true. It's a denormalized database. It's not yet as normalized as your SQL database. It's an in-memory view of the backend state, but it changes over time, but it's aggregate. Exactly like a materialized view in SQL. So when you use a materialized column view along with SQL, that's what it looks like. A decoded column batch in a column store, a cache line filled from memory. Redux state is not authoritative. DB is. It optimized for reads, cheap to recompute. So you kind of can think of it like the in-memory access in column storage. If there's an in-memory that optimized for writes because the column storage are optimized for reads, here, since the our database are optimized for writes, we will have an in-memory or a materialized view of the database that are optimized for write. Right, cheap to recompute, safe to throw away because it avoids mutation. That's why Redux hates mutation, because one of its properties is cheap to recompute because you just need to set a new instance of it instead of updating the actual data in that memory, because it's still in memory. It's fast. Same reason CPU hate uncontrolled side effects. Reducers equal pure functions equal CPU execution rules. Your reducers is equal will boil down to state comma action to new state. So that's the producer. You have a state and then you have an action and then it will produce a new state. So that's transformation, and that's what reducer is all about. This is equivalent to like instruction to data applied, or SQL relational algebra CPU execution with register renaming, ROB entry transformation. Why purity matters? This answer your earlier questions. System CPU needs purity because to speculate, reorder, rollback. System SQL needs purity because to optimize, reorder, cache. System Redux needs purity because to replay, debug, time travel. Redux DevTools work only because reducers are pure. Just like out of order execution works only because architectural state is isolated. So, or the ROB is in CPU architecture is isolated. That's why it's very easy to develop this app using Redux, Supabase, and React, or easy, and it's also easy to debug and uh, easy to add features. Redux dev tools works only because reducers are pure, just like out-of-order execution works only because architectural state is isolated, while works only because writes are ordered. Async thunks equal control side effects. These 9 export cons fetch comment equal create async thunk is the same separation as SQL planner versus storage engine, CPU frontend versus execution units, syscall boundary in OS. Thunk may touch the outside world, cannot mutate state, returns data only. Reducer cannot touch outside world, can mutate drop state via Emer. Deterministic, this is not accidental, it's the same design constraint. F, Emer equal register naming conceptually. When you write state.comments.push, argument new comment, Emer does copy on write, structural sharing, path local mutation. This is conceptually similar, not identical to register naming, speculative writes, commit versus discard. Important clarification, Emer does not change CPU behavior, it changes how your code uses memory. But the reason it exists is the same. Enable mutation like syntax while preserving immutability guarantees. Same motivation as ROV, MVCC, WAL. UI components equal pipeline consumers. Your components use app selector, argument state to state.comments are like execution units reading registers, queries reading volume vectors, instructions reading cache lines. They do not control when data arrives, how it is stored, how it is fetched. They only declare dependencies, react to changes. This is why you felt SQL feels abstract, Redux feels abstract because control is inverted. Why this finally answers your mental block. You kept asking, why is this so hard? Why does this feel different from loops? Why do we uh why do we do this instead of just mutating? Here's the real answer. You cross from instruction-oriented thinking to data flow-oriented thinking. Old mindset, do steps. New mindset, declare transformation. Old mindset, control flow. New mindset, data dependencies. Old mindset, mutation. New mindset, replacement. Old mindset, local reasoning. New mindset, global optimization. That's why SQL feels weird. Redux feels weird. Column store feels weird. CPU pipelines feel weird. They all remove local control to gain global performance, correctness, and observability. So they kind of abstract it. So it's really hard to know what state of the action and the new state your instruction applied to the data is. That's why it sounds unpredictable, but it really boils down to instruction and data being performed. That's also why it's hard to debug code because it can be unpredictable because it removes the local control to gain global performance, correctness, and observability. That's now today what you do, especially with AI, you just declare the UI, the problem, or with code, with the actual code, you declare transformation and the data dependency, replacement, and global optimization. Fourth, how your common features proves you get it. Your common features show you now understand domain state versus UI state, shared truth versus ephemeral state, side effects versus pure transformations, storage versus cache versus view, why mutation must be controlled. So the cache kind of like that's where the Redux is, the view is the uh, React, and the storage is the database. The side effects kind of like the backend, it doesn't know how that data from the database will affect the data. And a pure transformation is the side effects is what the back end, it consider the race condition, while the pure transformation are being defined by the front end and the back end. And the shared truth is in the database, ephemeral state is in the UI, or what the customer see. Why mutation must be controlled. This is not beginner thinking. This is systems thinking. One sentence you can say to Mr. Charles, the common features reuses the same architecture as blocks. The database is the source of truth. Redux acts as in-memory materialized view for reads. Reducers are pure transformations that allow replay and debugging, and file uploads are separated into object storage to keep raw data efficient.